Let's talk about using an interface as a type. When you define a new interface, you are defining a new reference data type. So interface can be referenced. When you reference the interface, you provide a data type, which is all natural. You can use interface names anywhere you can use any other data type name. Nothing special about the interface. It's just a type. If you define a reference variable whose type is an interface, any object you assign to it must be an instance of a class that implements the interface. As a variable, you need to assign the interface something. What you assign to the interface? What you assign to the interface is an instance of a class. That class needs to implement the interface. Okay, here is an example. We have a method accept two objects as parameter. The objects then cast to relatable inside the method body. Since they are cast to relatable, they will be able to call the isLargerThan method, which is defined in the relatable interface. Then return which one is larger. So by casting object 1 to relatable type, it can invoke the isLargerThan method. Object 1 called isLargerThan. Object 2 needs to have the same type as object 1, otherwise isLargerThan will throw runtime exception, maybe class cast exception. So here, if you make a point of implementing relatable in a wide variety of classes, that means the sum is books implementing relatable, students implementing relatable, and rectangular also implement relatable. The objects instantiated from any of those classes can be compared with the find the largest method, provided that both objects are of the same class. You cannot compare student with rectangular. Okay, you won't see runtime error, but you won't see compile error, but you will see runtime error when you compile them using the isLargerThan the implementation. So pay attention to this, provided that both objects are of the same class. Similarly, they can all be compared with the following methods. The only difference here is the direction. Instead of a larger than, it's less than. And here the same thing. It's equal. Let's play with those examples in Eclipse. Session 3 demo. Import the relatable. And we can also import the other, let's copy those methods too. Okay. And next, let's write, oh, damn it. Okay. Let's write a main function. Public static void main. And we first create a new session 3 demo. New session 3 demo. And then we call the find largest. We can create 2 new objects and see what happens. New object. We didn't see any compilation error, so that could be a trick question in OCA JP, OCP JP exams. There's no compilation error, but at runtime, you will see the class cast exception because the object cannot be cast to relatable. They didn't implement a relatable. Let's run the program. run as Java application. Okay, you see, you get the class cast exception at runtime. So what we need to do is we need to pass in some class which implements the relatable. Here, rectangular plus implements relatable. It also provides the implementation method, which we already go through in last section. So the other is cast to rectangular, then they compare the area. So let's create an instance of this class. A equal new 1 and 1, and of course we need to implement this class. And let's create another rectangular plus with different area. Then let's compare them, A and B. This find largest return an object, so we need to cast them back to the rectangular plus C, let's say, so that later we can print out their area in order to know which one is returned. C get area, C get area, okay. And let's run the program. Oh, we already, so let's run it. 4, okay, number 4. So the second one is largest, is we can find the smallest, play with the find the smallest. And this time, the A is smallest. Don't have to do the is equal because they just did the same. We can create a subclass of rectangular plus. So let's create one. Rectangle plus. You extend rectangle plus. Need to import rectangle plus, and here we need to give it a constructor so that it can have the parameter public rectangular plus. You get an int x, int y, and then you call super x and y to pass the parameter in. Okay, and here instead of create a rectangular plus, we can create a rectangular plus instead. And we didn't see compilation error, and if we run the program, we didn't see runtime error too. What happens is, if we go back, okay, these methods work for any relatable objects, no matter what their class inheritance is. When they implement relatable, they can be of both their own class or superclass type and a relatable type. So this gives them some of the advantages of multiple inheritance, where they can have behavior from both the superclass and an interface. Here, rectangular plus inherited the method is larger than. From their father, they have this method inherited. So when they are trying to compare, they know what the rectangular plus is. Also, they inherited the contract relatable. That's why we can do business with rectangular plus. Rectangular plus can have its own personality. It can have any method they like fancy behavior. Fancy behavior. Okay, you can do any fancy things. But from the perspective of find the smallest, their fancy behavior is irrelevant. All we care is you sign for the contract defined in the relatable, and you have implementation of is rather than. If you agree with the contract, we do business with you, no matter who you are. You get the contract from your father, and you implement this method, then we do business with you. It's all okay with us. That's all we care, and that's beauty of the interface. Okay, and in the OCA JP and OCP JP, we have we can have a trick questions. Say we didn't pass in rectangular process. Instead, we pass in a different kind of class which implement relatable. Let's create a class called book, which also implements relatable. Import relatable and add a so this one have a raw implementation. It didn't do anything, just return 0 all the time. And we create a book A. We don't pass in this. Equal new book. Okay. The trick part is you didn't see any compilation error. The book can be accepted by find the smallest because book is a subclass of object, and object is totally fine. It could be acceptable. And at the runtime, when the object is cast to relatable, it is totally fine because book also implement relatable. The runtime error is thrown at is larger than. That is a trick question. It can ask you what is the output of this program, and if there is error, at which line it will have runtime error. Your answer is at this line, runtime error. Or not runtime error, runtime exception. Particularly, it's a cast exception because it is larger than implementation in rectangular process. It's depend on the order. Let me say, not A, you should say B, because the A find the smallest, and the rectangular process find the smallest will try to cast other to rectangular, and you see cast exception. In the other direction, we will see different runtime exception, or we won't see exception at all. So let's run this program in this version first. Save. Okay. You see, cast exception is larger than find the smallest here. Rectangular process. When you try to cast a book to rectangular process, you see the cast exception. If we have a different direction, say where is A? It's book. B is not a book. In this case, you will see 0 return all the time. And this is a wrong answer. It's a broken program. Okay, you always see 4 because 0 is returned all the time. And if you find the smallest, you will always get object 2, which is rectangular. And this is a broken program. Okay, OCP could trick you in this kind of It's kind of a silly tricks. Just pay attention during the exam. Okay, we have covered using an interface as a type.